Our today's lesson will be real number system. Then our main objective is to determine the relationship between rational and irrational numbers. So before you start, we have a chart for you. When you were in primary or JHS, we learned that we learned about integers. And we said integers are positive and negative whole numbers. So we have negative integers and whole numbers. Then we continue that whole numbers contains 0 and natural numbers. And then natural numbers also has unit, which is 1, prime numbers, and composite numbers. And then unit, which is 1, is an odd number, and prime number can also be an odd number. And then composite numbers, some are even numbers. So our today's lesson will be based on the rational number and irrational number here. And then from rational number, you know that recurring decimals, terminating decimals, and integers are all rational numbers. Then irrational numbers, non-recurring decimals, non-terminating decimals, and square root of prime numbers are all irrational numbers. So we have some of the examples of irrational number, but symbol for rational number is Q, and symbol for irrational number is H. Then let's say we have 1. 1 is rational number because it is an integer. Then you have 2. 2 is a rational number. It's also an integer. You have 15. 15 is an integer. Definitely, it is a rational number. When you move to, if you have half, 1/2 is also rational number, which is in decimal form, it is 0.5. So far as when you can express it in decimal form and it gives you terminating or reoccurring, it is a rational number. Then you have 3/4. 3/4 is equal to 0.75. 0.75. Then you have square root of 2. Square root of 2 is irrational number. Why? Because when you express it in decimal form, it will be irrational. It will not be terminating or reoccurring. So in decimal form is 1.4142135562. And this is not even the end number. You have it will continue. Then you have square root of 5 is also irrational number, which is 2.23. Square root of 5 is 2.236067979949. It's also an irrational number. Then square root of 10. 10 is a rational number, but square root of 10 is an irrational number. Why? Because the product of two irrational number, which is different irrational number, will give you irrational number. So square root of 2 times square root of 5 will give you square root of 10, which is, so square root of 10 is 3.1627766016837. So here's the in decimal form. Then we have, if it is 0.25, so 0.25 is a rational number because it is terminating decimal. So you have 22 on 3, which will be 3.333, then continuing. So it is reoccurring decimal. It is reoccurring. 3 is reoccurring itself. Then you have 0.75. 0.75 is also rational number. Then you have square root of 15. Square root of 15 is irrational number. Why? Because it is in decimal form. It will not be what? Terminating or reoccurring. So it is, the decimal form is 3.87292983346210. Yes. We have 22 on 7 is also an irrational number, which is 3.1428571428571442. Yeah. So this is also an irrational number. Then you have pi. Pi is also an irrational number, which is 3.1459265359. It's also irrational. Then you have Euler number, which is 2.71828182845990. So this is Euler number. And Euler number is also an irrational number. This in its decimal form, and it is not terminating or reoccurring. Another instance that you know that this one is rational, irrational number is that when it is in the decimal form, it is impossible for you to convert it to a common fraction form. So that's another reason between rational and irrational. So rational number when you express it in decimal form, even if it is in a fraction, express it in decimal form to give you terminating decimal or reoccurring. But if for irrational, express that numbers in decimal form, it will not be giving you terminating or reoccurring decimal numbers. Then you cannot also convert it back to common fraction when it is in decimal form in terms of irrational number. As for rational number, if it is in decimal form, you can convert it back to a common fraction. So these are the examples of rational number and irrational